Hey everyone, how it goes? Welcome back to Computer Science 146. Today, we're going to continue talking about linking structures. In a previous lecture, we introduced the concept of a linking structure. This is a sibling data structure to an array, where this type of structure is able to grow and shrink, but in order to do that, we have to sacrifice random access. To best understand this, a linking structure groups together data with a link, in other words a reference, or in other words a pointer into what we call a node. Understanding this, we started going over a type of linking structure called a linked list. Now, as mentioned before, linked lists are linking data structures and they have nodes that contain data and a link. We also went over some very special types of nodes, which include head, current, and previous. We then started discussing the idea of generics. Using this, what we're able to do is create a linking structure that can be any type. Now that variable type, t, is the data for whatever we're creating, so it'll be a generic linked list of integers, generic linked list of doubles, of strings, whatever. This allows us to create one linked list that can be any type. Now with understanding linked lists and generics, let's see an example, and actually, this example is something that we've gone over before, but now we're going to do it in a slightly different way. We're going to be revisiting this taco problem. Now, if we remember back, the requirements for this solution was we need to be able to keep track of important taco information. So for each one of the tacos, we need to keep track of its name, its location, and its price. The software should be able to add a taco, remove a taco by its name, sort the tacos by their price, display all the taco information, store the taco information into a file, and also be able to read from a stored taco file. Finally, it also needs a clear and simple front end. From there, we started designing the software, and we're going to use a relatively similar approach. And as you can see, not much has actually changed inside of the software. We still have the class taco that can then be used to create instances of tacos that groups together name, location, and price. We have the taco manager front end that basically provides functionality to the user via the taco manager. The taco manager is where we're going to focus our attention today, because as you can notice, what we have right here, the element tacos is no longer an array. It's this generic linked list of this type taco. Now we can demonstrate this design in this way, but we can also include this generic linked list in our back end. This generic linked list was developed in a previous lecture, and we're going to use basically the same thing, but now group it together in our taco manager. So as we can see here, this taco manager has one instance of this generic linked list of type taco, and then this generic linked list has many tacos inside of it. You may also notice that this has an internal class, the list node, that groups together the data of type T, in this case taco, and also the list node link. It also has head, current, and previous. Each of these are list nodes that we've seen before. And also the functionality is like add, remove, all of that functionality that we developed before, but we just kind of shorthanded it for sake of space. Now, using this new design, we're going to recreate this solution, but instead we're going to use the generic linked list. Let's see how that works. As we can see here, we already have our project set up and ready to go, and we've included a couple of files. For instance, the taco, none of this changes, so we're still going to use that. We have the taco manager front end. Nothing changes inside of this, except you may notice that there's a syntax error on taco manager because, well, we've removed that and we're about to write that in a second. And also, we have the generic linked list that was developed in a previous lecture. Now what we're about to do is use this generic linked list inside of the taco manager. Now the first thing I'm going to do is I'm going to go ahead and create a new class and call it taco manager. And I'll put my name at the top. Now from here, I'm going to import a couple of classes that I'm going to be using later for file I/O. The first one, import java.util.scanner. That way we can read files. And also import java.io.star That way we can write to files and also we can handle a variety of exceptions. The next thing I'm going to do is I'm going to write some properties inside of this taco manager, much like I did before. I'm going to first focus on some of the constants. The first one is going to be our delimiter. So when we write to files, we're going to use a tab delimited file. And this is going to separate out the fields. In other words, the information that pertains to each taco. If we remember back, we have a name, location, and price. And whenever we write the file, we're going to separate it using a tab. That way, when we read back in the file, we can use the same information to separate, to delimit the name, location, and price. Also, you notice that we have this constant integer right here that corresponds to the body field amount. In other words, the elements that we require for each taco, the name, location, and price, 1, 2, 3. You may already notice a difference with this. Before we've even created the generic linked list, we are missing some of the constants that we used before. If we remember back, one of those constants was a default size. We needed to use this because arrays, they are fixed blocks of memory. We need to have that size in order to create a default array. But as we're using a linked list, we don't require a default size because linked lists, its greatest advantage is it can resize in memory. It can both grow and shrink. We don't need to know the number of elements before we create it. This also corresponds to the other constant, which was the head field amount. If you remember back, we had to print out header information that gave us the number of tacos that was printed to the file. We needed this because, once again, we were using an array. An array is a fixed contiguous block of memory that cannot be resized, so we need to know the number of elements. But as this is a linked list, once again, we do not need to know the number of elements, and we can actually just ignore writing a header altogether. Now, the next property I'm going to write is the actual data structure, private, generic linked list of type taco, and I'm just going to call it tacos. And there we have it. We have created a generic linked list of type tacos that we call taco. So this means all the functionality that we have already written inside this generic linked list can be used here. And as you can see here, we're using the type taco, which is substituted here. Every time we see T, it dynamically alters this to be taco. So this list node is taco data. This is the whole idea behind generics, because now we can make this generic linked list of any type, including tacos. Also, another big takeaway is the fact that we had already developed this generic linked list in a previous lecture, and all we needed to do was include this inside of our project. That way we could reuse it. One of the major takeaways of this class is learning about data structures and how we can create them on our own. One big element to this is the fact that we can use these data structures. We can reuse these data structures, and as you'll see in a little bit, we can also modify them to best suit whatever problem that we are solving. This gives us agency over how we solve these problems. Now, the next thing I'm going to do is I'm going to write the constructor public taco manager. Now, in the design, and also in the previous version, I wrote another method called init, and that was short for initialization. I used this, that way we can construct the array. But in this case, I don't really need to create that method, so I'm actually going to skip that. Inside of our default constructor, I'm going to now construct tacos is equal to new generic linked list of type taco, and call its default constructor. Now I've created a new instance of this generic linked list, this collection of type taco inside of memory. Now that it has been constructed, I can use all the functionality to add, print, add after current, get current, all of this information that I have previously already written. So now let's write some more functionality. The whole purpose of the manager was to maintain or manage the collection of information. So we're just basically managing this generic linked list of type taco. One thing we should be able to do is public void add taco. Add elements to this. and we'll pass in an instance a taco to be added. Now, all I need to do is add this instance passed in via parameter to this collection of tacos. So how should I do that? Well, going back to our generic linked list, I have this method that we wrote called add, which constructs a new list node that passes this data and assigns it inside of here, and then adds it to our collection. Well, we've already written it, so let's just use it. So inside of add taco, all I need to write is tacos.add a taco, and it simply adds that new instance of a taco. Now I'm also going to write a comment to do sort, and we'll come back to that in a little bit. Now we also need to be able to remove tacos, but specifically we need to be able to remove them by their name. Now this is going to be a little more involved. So we're first going to define public void remove taco, and we're going to pass in string a name. We're not removing a taco by all of its properties. We're not having to remove a taco by its name, its location, and its price. We're going to remove the first taco that has this name. What we need to be able to do is examine each one of these tacos and basically search for its name. Now this does become a little more complicated because once again, when we were doing this with an array, we had random access. We can start at index 0, the first element, and using a for loop, we can access every one of those elements in order to examine its name. But we don't have random access with this linked list, so we have to be able to access the elements in some way. Going back to the generic linked list, that was the point of having this reference called current. We can basically move this current reference around this linking structure in order to both access and modify its data. If I scroll down a little bit, getCurrent is a method that returns the data found at this current reference. It returns this type T. In our case, it returns taco. setCurrent allows us to pass in information, in other words, taco, a data, and then assign the current's data to this data. GoToNext moves the current reference forward in the linked list. Reset reassigns current back to the beginning, back to head. HasMore indicates whether or not current is null. If current has gone outside of the linked list, then we do not have more. Going back to our taco manager, what we want to do is reassign current to start from the beginning. We need to be able to examine the first element through all the rest of the elements. So I'm going to assign tacos.reset. This sets current to the head. Now we just have to keep examining every element inside of this linked list until we find an instance of a taco that has this name. So we need to iterate. We need to loop through every element. And I'm going to use a while loop. So while tacos.hasMore. In other words, while current is not equal to null. Now from here, we need to examine this particular instance. If tacos. Now we're able to access this information by calling .getCurrent. This returns the data that is found inside of this current link. So the way to look at this is the collection, the generic linked list of tacos. This is one instance of a taco. Now, what I need to be able to do is examine that taco's name. And I can .getName. Because once again, this is the generic linked list of tacos. This is one element. This is one instance of a taco. And this is that taco's name. Now, as getName returns a string, I can use the string method .equals ignore case. A name. Now once again, we have to examine every single taco inside of our data structure tacos. By calling getCurrent, I'm able to access the current's data, which will return an instance of taco. Using taco, I can call getName, which returns the taco's name. Then, as this is a type string, I could call ignoreCase, passing in the parameter name to verify, is this taco's name the taco that we need to remove? And if this evaluates to true, then I need to remove our current, which we've already written that, tacos.removeCurrent. And we'll go ahead and call break so it removes the first instance of a taco that has that name. Now maybe this doesn't evaluate to true, so we haven't found a taco that has that name, and maybe there are no tacos with that name at all. Regardless, we have to keep in mind that we're using current in order to access this information. When we reset it, we set it back to the head. When we determine do we have more, this checks whether or not current is equal to null. Now, if this evaluates to false, we need to move current forward, and we can do that by using tacos.goToNext. This will keep moving the current reference forward through our linked list until we find a taco with this given name, or we no longer have more. Now the next method that we need to develop is private void sort tacos. In our requirements, we needed to be able to sort the tacos by their price. And also, before I forget, I'm going to go ahead and going back to add, I'm going to call this dot sort tacos. Now we set this scope as private because when we were thinking about it, it didn't make sense to make this accessible outside of this class. Every time we add a new element, we want to sort, so sort is only needed to be called internally. So we have private void sort. Now we need to be able to sort these tacos by their price, but this can be a little difficult given our generic linked list. Now, as I was able to develop this data structure, I have the agency in order to add functionality to this linked list to make this part of the problem a little easier to solve. So what I'm going to do next is I'm going to modify this generic linked list in order to have some more functionality to make this easier to solve. Going back to the generic linked list, I'm going to go all the way back to the top, and I'm actually going to add a new property. This property is private int size. This indicates the number of elements, the number of nodes, the amount of data that we have inside this generic linked list. And for our problem, this will be the number of tacos that is found inside this generic linked list. Inside the constructor, I'm going to go ahead and set this dot size is equal to 0. Now, inside of add, we need to be able to modify the size every time we add a new element. So if the head is equal to null, so this is the first element we add to this linked list, I'm going to set this dot size is equal to 1. Now if the linked list was not empty, then all we need to do is call this dot size plus plus. Just add 1 to it. Scrolling down a little ways, if we add something after current, similarly this dot size plus plus. Increase the size as we add elements. Now we also need to do something similar when we remove elements. Now we could do size minus minus right here. However, I'm going to add a little safety check. If this dot size is greater than 0, then we'll do size minus minus. This basically ensures we won't have a negative size for any reason. So now that I've created this property, well, I need to give access to this property, so I'm going to simply write an accessor. Public int get size, and I'm going to return this dot size. Now there's 2 other methods I'm going to add to my generic linked list that's going to make this much easier. Now we're going to implement bubble sort in order to sort these tacos by their price. However, bubble sort can be much more easily developed using an array because we have random access. If you remember back, bubble sort, we check side-by-side elements to determine whether or not we need to swap them. Inside this generic linked list, we only have access to current. So this becomes a lot harder to evaluate whether or not we need to swap these elements. what we're going to do is create two methods. That way we can access information at a certain position. Much like an array, we're able to access a certain element at a position by using an index. We're going to public t get at int index. So using this index, what we're going to do is return the element found at that position. If this index was 0, it's the head. If the index was 1, if this index is 1, then it's one element after the head. In other words, the second element in the list. If the index was 2, then it's 2 elements after the head. In other words, it's the third element in this list. So the first thing I'm going to check is if the index, if this is less than 0, well, just like an array, this is incorrect, and we're going to return null. But also, we're going to check this as well. If the index is less than 0, or the index is greater than or equal to the size, this would also be an invalid index because this would go outside the bounds of our linked list this time. Now, once again, we want to get an element at this index, but we don't have random access. So what we need to do is start from the head and count that number of elements and then return it once we reach it. So I'm going to create a list node temp and assign it to the head. We need to advance this temp reference through our linked list until we reach this index. This tells me this probably should be a counting loop. So for int I is equal to 0, I is less than this index I++. Now, until we have reached this reference, we need to move temp forward. Temp is equal to temp.link. Now, once this evaluates to false and we jump outside the for loop, all we need to do is return temp.data. So let's just see how this works. If we pass an int index 0, that's the element at the head. We need to return the information that is found at the node that is referenced by the head. So we jump down to here. This list node temp is assigned the value of head. Int I is equal to 0. 0 is not less than 0, so we ignore this and we return temp.data, which temp is the head, which returns the first element. Index 0, position 0. If we passed in index 1, well, we start here. Int I is equal to 0. 0 is less than 1, and so what we do is move temp to temp.link, the element right after the head. Then we update I to 1. 1 is not less than 1, and then we return temp.data, so we return the element found at index 1, the second element of this linked list. We could do the same thing for 2. Starting from the head, we move it forward, 1, 2 elements, and then it returns the third element that is part of this linked list. By creating this method, now we can get any element at any position inside of this linked list. So now that we can get an element at this position, in other words, we can get an element at this index, we should also be able to set information also given this index. So we're going to create public void set at int index given t a data. In this case, taco. Now inside of here, we're also going to check if index is less than 0 or index is greater than or equal to the size, and also or a data is equal to null. We don't want to be able to set null information, so if that's also true, we just return without setting anything. Now, just like before, we don't have random access. So in order to access this element at this position, this index, we need to first start from the beginning. List node temp starts at the beginning, the head. Then we use a very similar for loop. For int I is equal to 0, I is less than the index I++. Then all we need to do is move the temp forward. Temp is equal to temp.link. Then from there, temp.data is equal to a data. So if we wanted to set the information at index 0, that's the head. So we start temp at the head, 0 is not less than 0, so this is ignored, and then we just set a data, the information passed in here, to what is at the head. And we needed to set the information at the third element. In other words, 0, 1, 2. Index 2 is the third element. It starts at the head, moves ahead twice to the third element, and then sets A data to the element here. So now that we can get the size of this structure, now that we can get information at a certain position, in other words, an index, and we can also set information given this index and this data, we can then more easily sort the information based on the price. So let's see that. The next thing that we need to do is implement a sorting algorithm, and once again, we're going to use bubble sort. So Boolean swapped is equal to true, and then while swapped, we enter this while loop. Now, we assumed swapped initially is equal to false inside of here, and then what we need to do is check each side-by-side element. Well, this becomes a lot easier to do because we can access and set any element giving a certain index. So, for int I is equal to 0, I is less than tacos.getSize. Now we have the number of elements, I++. One thing we're going to check, if tacos.getAt, this index I plus 1, is equal to null, we're going to go ahead and break because we've reached the end of this linked list. But otherwise, if tacos.getAt index I, if this element here, now remember, this is our collection tacos. This is one element. This is one taco, and we're sorting this based on the price. So as this all becomes an instance of a taco, we can then call .getPrice in order to get its price. Now, if we notice tacos.getAt index I plus 1, the element right beside index I, and its price happens to be less than this price, then we know they're out of order and we need to swap them. In order to do that, I'm going to first assign taco temp is equal to tacos.getAt index I. From there, tacos.setAt index I is reassigned the data that is found at tacos.getAt index I plus 1. We effectively get the neighbor's information and set it to where we're at. Then we reset tacos.setAt index I plus 1 to the temporary value here. And we also make sure we assign swapped is equal to true. This is one way that we can implement bubble sort using a linked list. It does make it a lot easier if we can get certain elements at a position, in other words an index, and being able to set information at a given position, in other words an index. Now we only have a few more methods to go. The next ones we're going to focus on is file IO. And the first one, we're going to write a taco file. Public void write taco file string a name. Now inside of here, we're going to go ahead and create a try and a catch block. We know that file IO is fraught with all sorts of exceptions, so we need to be able to catch those exceptions and handle them. Exception E, and then inside the catch block, e.print stack trace. That way, if something did go wrong, we can figure out where. The next thing we need to do is create a print writer, file writer, is equal to a new print writer, a new file output stream with a name. So this constructs a new instance of a print writer. This constructs a new instance of this file output stream, and given this file name, we're able to either create a new file with that name or overwrite an existing file given that name. In the previous example, the first thing that we printed out was that header information that gave us the number of tacos that we had inside of that collection. However, we don't have to worry about that now. Since linked lists are resizable, we don't need to print out that header information. We could just focus on the body. So we're going to use a very similar means that we saw before. We want to basically start from the beginning of the linked list and print out the information for every taco. So what we do is call tacos.reset. Remember, this sets the current reference to the head. Now we need to loop through each element, so while tacos.hasMore, while current is not equal to null, then what I'm going to do is assign taco a taco is equal to tacos.getCurrent, the information that current is currently referencing. Then I can use FileWriter.println to print out this taco's information. So I'm just going to call a taco.getName plus delimiter. To make this a tab delimited file, we separate the name using this delimiter, then a taco.getLocation plus the delimiter plus a taco.getPrice. So this separates the information. It delimits the information, the name, the location, and the price by using this tab. And as we called print line, this then adds an end line character to the end where it jumps down. That way, for each instance of a taco, it's separated by an end line, and the information pertaining to each taco, the name, the location, and price, is separated using a tab. Now we need to be able to move current forward after that, so tacos.goToNext. So we start from the head. While we have more, we get the current information, print out its name, location, and price, separated by a delimiter, then call goToNext, and outside of this while loop, FileWriter.close. Don't forget to close the stream. And now we can create a tab delimited taco file. Another point to note is that we could actually solve this in a different way. Using the methods getSize and getAt that we just developed in our linked list, we could redevelop this using a for loop instead of a while loop. We could use the for loop to iterate through each one of the indices. In other words, each one of the nodes that's built into this generic linked list in order to print out this information. By developing these data structures on our own, we have the agency to modify them and actually develop solutions in a variety of different ways. Now let's read this information. Public void read taco file, string a name. Now, just like writing a file is fraught with all sorts of exceptions, reading a file is no different. So we need to create a try and a catch block to handle any of those exceptions. Exception E. Then inside the body of the catch, we're going to call e.print stack trace. That way, if something goes wrong, we can figure out where. Now inside of here, we're going to create a scanner, file scanner is equal new scanner, new file, a name. Now we're using the scanner to scan through the file. We're then pulling this information from the file, creating new instances of tacos, and adding that to our collection. So while the file scanner has next line. Remember, each instance of a taco was separated by using an end line character. Now what we're going to do is the recommended process where we read the line. In other words, we read the information that corresponds to an instance. We then split the line. We separate the information given a delimiter into each one of its properties. We then check the line. We make sure that we have the correct number of fields that pertain to this object, and finally, we apply. In other words, we create a new instance of a taco and add it to our linked list. So first things first, read the line. String file line is equal to file scanner dot next line. This reads everything up until that end line character. From there, we need to separate the information. String array split lines is equal to file line dot split on the delimiter. This will create an array where index 0 is the name, index 1 is the location, and index 2 is the price, all as a type string. Now we need to check this. If splitlines.length is equal to body field amount. Now, if we remember back, this was assigned to 3 because this array should be of size 3 because there are 3 elements: the name, the location, and the price. If we don't have exactly 3 elements, we can assume that this is incorrect and we should just ignore it. From there, we can now use this information to create a new instance of a taco. So for instance, we can create string name and assign that to split lines at index 0. As split lines is already of type string, we just know that the first element, index 0, is its name. Similarly, string location is equal to split lines at index 1. After this is separated using a tab, this becomes index 1, its location. And finally, double price is equal to double.parseDouble, split lines at index 2. Now we know this price is of type double. Now as this is an array of strings, we need to use double.parseDouble in order to convert the string split lines at index 2 into an actual double. Now once we do that, we can construct a new instance of a taco. Taco a taco is equal to new taco with the name, location, and the price. Now, just by reading this line in, splitting the line apart into the important information, using that information to create a new instance of this type taco, we can then call this dot add taco, a taco, and add it to our collection. We have thus converted the information that was stored into a file as a simple string into an object, into an instance of the class taco. Now, outside of this while loop, we need to make sure to close the stream, so file scanner.close. There's only one more method left, and we need to be able to print out the tacos. So public void print tacos. Inside of here, we could just call tacos.print. We've already written this method inside of our generic linked list, and it's going to print out all of that information. Now let's check the functionality to see if all of this works. Running it? Well, let's add a taco. Let's do ASDF, and let's say it's $1. And as you can see, this added this new taco with the name, location, and the price to our collection. In this case, to our linked list. Let's add another one. ASDF2, and let's say this one is 50 cents. Well, as you can see, it added this new instance of this taco, and it sorted it based on its price. Let's add another one. ASDF3, let's say $5. This one got added at the end because it had the highest price. Let's add another one. ASDF4, let's say $3. And see, this one got added in the middle. It's keeping track of every element in this linked list, and it's also sorting it based on its price. Now let's test out writing this to a database file. So I'm going to select 4, and I'll call it tacos.txt. And so it printed out all this information. We'll come back to that in a second. Now, let's see about removing a taco by its name. We'll say ASDF, and as you can see, it removed the information from here. I'm going to go ahead and quit, and I'm going to rerun this, and the next thing I'm going to do is read from this taco database, tacos.txt, and here's all the information that was stored into the file, that was read in from the file, and now we have this linked list with these tacos. In this lecture, we've gone over how to use a linked list in order to solve this problem. Once again, the linked list is a sibling data structure to an array. The greatest advantage of a linked list is it is resizable in memory, but we sacrifice random access in order to do that. We've seen in this example, by doing this, it makes certain aspects of this problem a little easier and other aspects of this problem a little bit harder. These are trade-offs that we need to start recognizing as we solve these problems. But another large takeaway is the fact that we created this data structure on our own. And by doing that, we can reuse this data structure. We were able to use this generic linked list by adding it to our project. And in fact, we can use this in any project that we develop. Also, by developing it ourselves, we have agency to modify the data structure to add functionality or even potentially remove functionality. As software engineers, we need to be able to recognize the advantages and the disadvantages of using these different kinds of data structures. That way, we can solve the problems in the best way possible. And with all that being said, I'll see you next time.